I think I finally got all the bugs worked out in this, so while I'm starting this, if you guys have any questions, you can just post them in chat. But I think good. Okay. Whip up a REPL to show some examples here. And so there was one thing I wanted to mention, and that was about the assignment. All right, if you, let's see, I guess I should look at how many people turned it in. Okay. Well, good. All right, let's see how many people turned this in. Okay. I'm not missing a video, am I? Trying to figure out if I forgot to put one of the logic lectures in there, but I guess not. Okay. So we're going to take a look at Chapter 4, and it looks like a lot of you folks have already figured it out. So if you're working ahead and you have questions on later material and you're here, definitely feel free to ask those questions. Since you're here, you know, take advantage of it. We'll mention these as we look at the examples. It's kind of a big info dump, so. Okay. So basically the idea is you need to understand how a computer program is interpreted by the computer from the code. And so I think everything that we've done in this class, I'm 100% sure, has been in a sequence. It's also called procedural. Basically, it's a list of directions, and it just always follows the same path. All right? And so when you introduce, if statements, trying to see if there's anything usable in here. Geez. Is this only about flowcharting? I think it is. Okay, well, for the people that completed the Chapter 4 assignment, let me pull it up here. Did you guys feel lost, or was it really simple for you? how do you feel about it? Because I'm not sure. All my other classes are being very vocal about what kind of problems they're having, but let me know if it's too easy. All right. Don't need this anymore. Okay. So I guess we might even just look at chapter 5 then. Make it a little easier to see here. Yeah, if sometimes I'm not thinking about how well you guys can see this or not, so if you're having problems reading anything, tell me, I can zoom in. Okay, so that chapter 4 was asking the programmer's workshop. Oh, there were some people asking me about where to find this in the chapter. So the programmer's workshop is like in the middle, usually. There we go. Okay. Annual interest for savings account. Okay, so the actual program itself isn't, was there anything in there that was difficult for anyone? Feel like it would be a waste of time at this point for me to do an example, unless you guys want me to. Also, if someone could just say something in the chat, sometimes for some reason sometimes it locks up, and so if you can't chat in there, if no one says anything, I'm going to assume I need to fix the chat. All right, chapter 5 is talking about selection structures. So, depending on who you learn programming from, what book you look at or what website you look at, everything's going to be called the same thing is going to have 38 different names. All right. So, does anyone in here, is anyone familiar with more than one programming language at all? Oh, thank you guys. Anyway, when you're learning one, they're going to throw all these terms at you, and it's not that they're not important, it's just there's a lot of fluff, especially in a textbook. So I kind of trying to skip over that for the most part here. All right, here we go. This is some good stuff. All right. So the reason chapter 4 talked about flowcharts is they were trying to say that using a flowchart is a good way to plan out a program. Okay, and that's true if you are making a very large-scale project that may involve multiple people working together. You would use a flowchart. If it's something you can sit down and make in an afternoon, not only is it a waste of time to create a flowchart, but it's not going to make any sense. Has anyone tried making any flowcharts in here? Let me know if how you feel about the flowchart. If anyone's done them, let me know how you feel about it. In my opinion, this class, the first programming class you shouldn't even be aware, there's no frame of reference for where a flowchart is used until we get to the capstone course. But besides that, they actually are good at illustrating how a program works with selection structures, which are just if statements. And if you're not familiar with these, I'll be talking about them today. But if statements, if else, else if, and I don't think they're doing loops in this one. Oh yeah, there's the summary. Okay. Okay. So we're just focusing on those selection structures. Now I'm going to keep saying it because it's stuck in my head. But this is talking about basically if statements in any programming language. I'm not sure if, except for maybe functional programming languages, I'm not sure if any programming language does not include a selection structure if statement, basically, because it's kind of important. All right, so okay, they talk about all this. Let me just show you in JavaScript. Maybe. Right. Throw some junk in there so I don't spend forever trying to think about what to name things. So if statements. So the most basic structure here for selection, and they're talking about selecting the path that the program is going to take. This is, if you just use an if statement, you're basically adding a detour, a short detour in your program. Well, I guess you can make it as long as you want, but it's just a blip. It's just some extra code that sometimes will run or not, depending on the expression used, or the way the expression evaluates. All right, so inside the parentheses for an if statement, you always have to put an expression that can evaluate to true or false, which are Boolean values. So if you put, well, we've talked about numeric data types, so like string and, or I'm sorry, integer, and then down here is a string. Trying to do too many things at once here. Apple equals, sometimes it's caps in some languages and sometimes it's lowercase. Anyway, you'll notice the color coding makes these values blue. And does anyone remember what this blue color represents in JavaScript? So the colors are highlighting things that are, are part of the same group or whatever. So you'll notice, and I'll show you here. I use let, but the book uses var to declare variables. So I hope that isn't throwing anyone off. The difference is hard to explain, and in this class it wouldn't be important to understand it, but when we get, if you continue on and you take Web Scripting 2 and the capstone course, it'll be very important at those points. So try Googling it and let me know if you figure it out. All right, so you can have these Boolean values. So we have numeric, alphanumeric, integers, strings, and so these are Booleans. So it's oh, that's going to be annoying. Two values that I'm just going to have to turn this off because it's going to keep bothering me. I had this extension last night that I installed and forgot about, and when I was grading stuff, I selected a word, and I had my volume up really loud for some reason, and so the computer just yelled this word out randomly, and it scared me. All right, so that should fix that. All right, can I get through one thought without being distracted? Anyway, so we're introducing this new data type. All right. Rarely are you going to be storing this, declaring it in a variable like this. This is just for demonstrative purposes. So, whatever you put inside the parentheses here will have to evaluate to true or false. So if we do this, well, let's not name the variable the same thing, huh? If x whoops, now I'm doing Python document dot write. So let's put it in the console. Console.log. Okay. They also mention nesting in here, which is extremely important with selection structures. You can basically map out something very complex just using this. Up to this point, what we've been doing in programming probably doesn't seem all that useful, and it's true. Nothing we do in this class is teaching you any things that you would need to learn to work in the real world. Okay. I'm not trying to say this is useless information, but it's just to get you familiar with a programming language so that when we move to the next one, we don't have to go over all this stuff again. Or if we do, it's very short because it's just different syntax. All right, so we want to check if banana is true. We want to check if apple is true. And we want to check if zebra is true. Now, you guys can probably guess what some of these are going to evaluate to, but why don't you try and guess which each one is going to evaluate to. So either post it or write it down or just think about it. Or if you have no idea, just pay attention, I guess. All right. So what we've built here is basically 4 different detours in my program. And so understanding what this looks like in terms of the flow of the program is one way, honestly, just to illustrate the branching. The flowchart is actually not bad. So a flowchart is a planning tool. Okay, if you have no idea what you're doing, planning is a good place to start on some sort of project where you're doing something that no one's done before, right? In this class, we are just basically regurgitating, code, so you get familiar with the terminology and get more comfortable with trying things. Okay, you gotta try to figure things out. Jeez. Alright. I don't know why I try to use that. Okay, we'll just save it to my documents. Alright. So, what I'm saying is, unless you are having trouble understanding some complicated nested if statements, what I'm showing you with flowcharts is just for me to explain this to you. All right. So, also, if you like this part of programming, you should look into something called finite automata and a Turing machine. Some very, very basic computer science and programming topics that'll help you understand basically how everything works. Kind of takes the magic away from programming, but gives you a lot more that you can do. All right, so we're going to check X. I like how the flowchart was like the exact opposite of what I needed. Oh, that's right. Okay. Okay. There's that. Changed laptops, so I'm not used to this keyboard. That's my excuse. Is Y true? So as I'm doing this, if you guys have any questions, make sure you ask. I'll check here. Oh, okay. So I got a new laptop because of all the problems I was having, and what I needed was something that could process video faster, and so I had to get a gaming laptop, and it gets very loud, but I think I can I'll figure out how to do that. Let me know, Alex, if you can hear any better now, or if you can still hear that. I'll try to talk louder, too. All right. So what we created looks something like this, right? We're checking 4 values, but since the if statements are all on the highest level, all right, and this is a reason we also use indentation to denote blocks of code, all right? And you can see Replit is a pretty good text editor. It gives you this option of basically minimizing your blocks of code. But that helps you see this if statement is only affecting this line of code here. So regardless of whether this value is true or false, every line after 7 is going to run as far as this knows, at least the if statements are going to run because they're on the outermost level. So the only way the code inside of the if statement is going to run is if the expression evaluates to true. So here we have 7, if 7, print out x is true, if banana, so if r, banana is true. Let's see what it does. And remember to put my things in here. Okay, so look at what the output is here. And you think about it for a second. This is something that if you don't know on a low level how computers work, may be fairly confusing, but once you understand what's happening, it can help you understand more about how a computer works and takes commands. Okay, how is it now, Alex? Let me. I think I can test my mic here. I spoke too soon when I said I worked out all the bugs. You know what? I have a. Oh, it's using the webcam. Oh, okay. That makes a lot of sense. Or it's using the webcam's microphone. Okay, I'm going to run a test. So. Hello, can you hear me? All right. I'm not sure. I might have to actually refresh the live stream to get this audio in there, or I have to restart OBS. All right. Well, let me know, Alex, if it's too... Actually, you know what? I'll just listen to it on my phone. There we go. I don't know. This is not a waste of time, by the way. So this is actual, potentially how you would debug code. So we're trying to identify what's causing the problem. So you want to start with the simplest and most wide-reaching thing, and then work your way in. Yeah. Okay, let me see what I sound like on my phone here. Okay. Yeah, I hear it. Well, if it's bothering anyone to the point where you feel like you're not going to get the most out of this lecture, let me know and I'll put more work into fixing it here. Oh, good point. Okay. I think, man, having this throws me off. All right, I think I can throw in audio input of. Nope. Create new. There we go. Let's have it use the laptop mic. And then we'll see if that helped anything. Oh. You guys can't see me. Can you? Now I'm just making it worse. Okay. Doesn't seem to fix it yet. I'll have to hammer away at it someday. Yeah, no, I'm glad you mentioned it, Alex, because I've stopped having time to go back and edit these right now, so I would probably never notice that unless someone complained about it, so I appreciate that. Okay, so I need to do... Oops. Okay, well, I'll figure out how to get me on there. Oh, later. You don't want to see just the top half of my head the whole time, right? Okay. Anyway. Back to this. When I edit this, I can just chop all that out. But you guys had to suffer through it, I'm sorry. Alright. So you've had plenty of time to think about this question here. So, if we have Boolean values, let's try another one here. Obviously, since zebra was false, that didn't print out. Right. And then, what is this? Do you guys remember what this is called? Where you don't assign a value, you just give, you just reserve a name for a variable. So that is just variable declaration. So that's just declaring the variable, which, let's see what happens. You guys have probably done this on accident, but I can't remember what happens in JavaScript when you try to print out an uninitiated variable. This is something that, JavaScript is really popular, and it's part of a lot of web apps, obviously, and things, but it has a lot of little quirks because of the way it's implemented on top of browsers and the way it works with browsers. Right. Oops. So, this should help you understand why X and banana are evaluating to true. Let's see if you guys guess. Whoops. Oh no. Okay. Let's see. I promise that I am a competent, functioning human, and this is just a fluke, just like all the other ones were flukes, right? Anyway. Make sure it's not doing that still. I should just always have this in the background. I have to be the producer, the director, and the actor in this. Or the presenter, anyway. I wouldn't say that I'm acting right now. Okay. All right. Oh, the video capture, right. That has audio output. Oh, there we go. This is definitely not my forte, but I'm getting a lot better at it. Alright. It's not double miking anymore, is it? Alright. Should we just start class all over again? Am I actually going to get to teaching a full idea here? Okay. So let's talk about why. Okay, I'm going to focus on one thing. I want to finish this, and then we'll check the chat. Okay. So here we're evaluating x. X is 7. How is that true? Well, when an expression evaluates to any value, JavaScript's going to consider that true. And so what you can do is use this as a test to see if variables have been initialized with a value or assigned a value later. That way, you don't go on using that variable when it's empty, because here we're not getting an, oh, we are getting an error, but oh, it only spits this out, doesn't it? Does it? Okay. The reason it spits out that undefined is one of those JavaScript quirks. Okay. So 7 is true because x contains a value. So it's not really that 7 evaluates to true, it's just that x, the variable, has a value, so that always evaluates to true. Before I commit to that, because now I'm having memories of other things, but I might be thinking of a different language. Either PHP or C++ or something. Okay. -1 is true. And then here we'll go 0. Okay, so we'll see. I feel like if you type a colon instead of a semicolon, that's not an accident. How could that have been happening? Okay, so even -1 is true. Any value, I believe, let's double check that. Any value in JavaScript evaluates to true. Ugh. There we go. Alright. I don't think this has to do with... Okay, here we go. Here's 3 values that should evaluate to false. Null, undefined, and nan. Let's talk about those. Talk about all the weird things. I'm not sure if it'll let me just implicitly put those, though, or explicitly. No. Okay. And N-A-N. There we go. Oh, I was trying to say earlier, the blue it refers to reserved words in JavaScript, so you can't use them as like a variable name. So we can't do like let, or var. Those words are reserved. So when you run a JavaScript file, it runs through an interpreter, so each line of code is ran through the computer all the way down to the hardware level. And before it even gets there, when that interpreter, it basically just reads the code one line at a time. When it gets down, when it sees a reserved word, that's telling it to shift gears into something else. So when it sees let, it says, okay, I know I'm going to get a variable. And so here, it's going to be confused because I'm saying, okay, get a variable, but there's nothing, and then get another variable. And so then you get this error written by someone who likes to use big words. Let is disallowed as a lexically bound name, which is exception, or actually this is a syntax error. Learning to interpret these errors will help you. And in the beginning, just copy and paste them right into Google, and you can learn more about how it happened. If you know that, it helps a lot. But anyway, let's not do that anymore. But we got our special values in here. What was the other one? Undefined. Okay. So anyway, you know when you run a program it says undefined at the top, that is actually the object that gets returned by JavaScript. Just at the end, it just returns undefined. Alright, let's see how these work. Okay, let's see if it's this. Yeah. Null with a lowercase n. Wondering why that was green. I thought it was warning me, because you don't want to use null if you can help it. It does weird stuff. So, undefined didn't show up. Well, I didn't put it in there anyway, but these didn't show up. These are values that are false. And so, you don't want to end up with a null, you don't want to end up with this, and you don't want to end up with this. So, you can use an if statement to check if a value becomes one of these. You could fix the problem, potentially, later on when we actually have the ability to build something more complex. Alright, so this is the easiest, the easiest part of this chapter is just understanding how an if statement works. Alright, and don't forget to think about it just with if statements, no nesting, no else. We'll talk about those here in a second, but this is what it looks like. The flow of the program looks like this. All right, and like I said, this is a good example just to see. This is just an optional block of code that might run, might not. It just depends on what values are used. Okay. Oh, is the audio getting worse? What the heck? I have a separate mic, I should just use that. Okay. Let me grab that real quick. Hopefully this carries through to these programs, but it probably won't. But if I have to redo this lecture later, that won't be a big deal. Alright. Let's see. Are any of you guys' other classes this bad? I guess, you know, I'm trying to not use Zoom because everyone else is. And so you guys are suffering through over here. Ugh. I hear the double now. Yeah, I just... Oh, okay. Let's see. Okay, so use capture audio. Just set this back. I haven't messed anything up. Okay. Now I'm gonna try restarting here. Just the program. Okay, let's see how well this works. Okay. Does that sound crisper? Sounds so quiet. Dang it. Alright, I tried adding some more volume. See if that helps. Oh, good. Okay. Whew. Let me try raising this audio one more time. Oops. By the way, if you're watching me adjust this values, I have no idea what I'm doing. Okay. Oh, yeah, the auto-tune. I wonder if I'm... What else? Oh, you know what? Wow. I think I just had my volume down. Anyway, can you guys still hear me? Oh wow, the mic wasn't plugged all the way in. That's embarrassing. Also, I lost the tripod somewhere on my desk, so it's just I just have to like set this over here. Okay. Alright. This will be a good time to mention that advising is coming up, so if anyone wants to schedule a meeting with me to talk about the easy part is telling you what classes to do, but I want to know what you want to achieve. You know, are you here just for knowledge? Are you here for getting a job? So that way I can kind of guide you through. And I promise I'm a lot better at that than I am at this so far. Okay. Let's stop looking at the top of my head. Okay. Scary. All right. So, I think that is if statements. All right. I think we're going to go over nesting last. I do have a class at 2:30, so I'm going to go to 2:20 probably. You guys remember you can rewatch, you know, come back and watch it anytime, but let's take a look at, well, I guess we should talk more about expressions that evaluate into Boolean values. So, besides just, and this is other than what I said before, which is error checking, or basically preventing values from getting into places they're not supposed to, you can also create a more complicated expression. So if you can use greater than or less than. Okay. Oh, one important thing is you'll notice I don't put, I'm doing this on purpose. I'm not putting semicolons at the end of the if statement. Okay? Remember what the semicolon is for, and then tell me why it's going to break the if statement if I put a semicolon after it. Try to think about, you know, what would cause that. Okay, so so it prints out this x is true, but if I put a semicolon here, right? And actually, let's do it on one that's false too. Apparently 0 is false. I didn't even pay attention to that. So the reason that is inside a computer at the lowest level, everything's stored as binary, and so there is no true or false in terms of, you know, how we think about it. It's literally just two different values, and they're usually represented at the lowest level by zeros and ones. So true often can be represented by a 1, 0 represents false. I don't know if that's true for every programming language, but it is here, and it's easy to look up if you want to know for another language, but we'll talk about it in the other classes. There's just a few syntactical differences, and anyway, we're only using this language now, so I should focus on that. All right, so let's see what happens. So here we have a semicolon after the if statement, and it's printing it out here. I've accidentally created a super deadly bug here by doing this. Okay, and you might figure it out. Any kind of a bug that this is a logical error. Well, let's look at the other one real quick. Down here we had 0. Remember, 0 was false. Okay, but I put a semicolon after it. Why did it print out 0 is true here? All right. And so if it's printing this out when this is false, how do we know if it's printing this out because it's true? It's not. What's happening is, and I might have said this before, all of your computer code that's written in JavaScript, you could theoretically just write on one line. Remember, the indentations are just for us to organize our code and make it easier to read. Now in Python, you do have to indent. That's how it knows where the blocks of code are. But in JavaScript, statements are ended with semicolons, and blocks of code can be denoted by curly braces, which we'll see here in a second. But what's actually happening on line 8? Let's see if anyone said anything. Nope. Okay. Well, think about it. Pause if you want. What's actually happening is this. All right. What does this mean? So you don't put a semicolon after an if statement because this is an empty statement. What it means is, if it's false, skip over line 9. Okay. If it's true, run line 9. Well, there's nothing on line 9 here. Okay. So if you put this here, what it's doing is basically taking up the block of code for the if statement. And if I was testing with just this and I didn't notice that semicolon, why would I think it's wrong? Because it's spitting out what I expect, right? Only if I got a false value in here would I notice something is wrong. And so this would be a very hard issue to even notice, let alone solve in a lot of implementations. And I'm actually going to write it down. It's really hard to come up with logical errors off the top of your head. It's like, I can't even think of an analogy for it. So we have two types of errors. Okay, you guys have probably encountered both at some point, but We have syntax errors, which it's basically you're trying to put a circle in a square hole, a large circle in a small square hole. That's what a syntax error is. All right, you threw a wrench in the gears. All right, and you usually do it because of a typo. Okay, or you just forgot the syntax. A lot of times when I'm programming something in any language, I will try to remember the syntax, and then if it breaks, then I look it up. So we don't want semicolons here. Okay. I feel like I didn't finish that thought, but oh, right. Syntax errors, that's just where you're using improper grammar is what it is. And so the computer just gets confused. Okay? You're asking it to do things it can't do. Or it has no idea what you're trying to say. And they're usually easy to fix because the whole thing will break if you have a syntax error. The more insidious type of error is logic errors. Okay? Both errors are entirely the programmer's fault, which you have to swallow your pride, and it's really easy when you're programming to want to, smash your monitor when it won't work after 8 hours, but don't do that, and you have to swallow your pride and realize the computer it doesn't think. It just acts immediately when you tell it to act. So if it's not doing what you want, it's because you told it wrong. Computers are very stupid in that regard. Okay. It's not going to correct errors for you. Oh, so a logic error would be something like you typed a formula wrong, so the wrong number is coming out for your output, or you put a semicolon after your if statement so that the if statement triggers off of just that one block of code, which is nothing, and then it runs everything after that. All right. So in all of these examples, I'm going to have to stop here, but let me finish this one thought. In all of these examples, we're only putting one line of code after our if statements. Okay? If I try to put a second line of code, let's do it here where we know it's false. So it's not, okay, let's run it before we change it, right? Because 0 evaluates to false, so it's not going to print out 0 as true. And if I put this line here, it will say 0 is true. Okay, but maybe I want both of these to run only when this is true. Okay, how do I do that? Well, you can define your blocks of code, your code blocks, with curly braces. Okay, so now it should not run either of those because they'll only both run if this evaluates to true. Right. So this allows you to add more than one line of code to your if statement blocks. And I wonder if they have an example in here. I'm going to have to go here. What am I looking for? Where am I? What am I looking for here? Nope. I lost it. Okay. Anyway, I'm going to end it here for now. Wow. Top of my head. Alright, so ugh. I have to figure out how to fix this camera. Anyway, I'm going to end it here. Since we didn't really get to go over that much, try it. Look at the examples in the book. Google examples if you want. And you can always email me or I guess that's, message me on Canvas. All right. So, have a good day.